ground as power supply voltages. If ground means its value should be 0 volt. Ground means its value should be 0 volts. In the year of 1980, the value of voltage fixed to VDD is 5 volt, but its value should be decreased in modern processors. Nowadays, the value of VDD should be 1. So, its value is decreased in modern processors. Here, the IVDD, if the power supply VDD becomes I, it may damage the modern tiny transistor. If it is low means it saves the power. So now the value of VDD should be decreased from 3.3 to 2.5, from 2.5 to 1.8, 1.5 to 1.2, and from 1.2 to 1.0. Now the value of VDD is 1. So the value of ground is 0. So in power supply voltages, you need to remember 2 points. The value of VDD is 1. But in earlier days, its value is 5. When the days goes on, its value become decreased to 1. And the value of ground is 0. Next, we're going to discuss transistor as switches. So as we know that we can view MOS transistor as electrically controlled switches. We can view or we can say that the MOS transistor as electrically controlled switches. The voltage at gate controls path from source to drain. Suppose if you consider either NMOS transistor or PMOS transistor, so the gate controls the current flowing between source and drain. The voltage applied at the gate which controls the current flowing between source to drain. So now we're going to discuss how the transistor will be accessed. Now we're going to see how NMOS transistor and PMOS transistor will access switches. First, let us consider NMOS transistor. So this is the symbol of an NMOS transistor. So we are having 3 terminals. One is gate, the second one is drain, and the third one is source terminal. So this is a circuit symbol of an NMOS transistor. Suppose if you are providing 0, if you are giving input voltage at the gate is 0, as we know that the NMOS transistor should be on, only its value is 1. If you are providing 0 means it is off. When it is off, it is an open circuit. Then there is no current flowing between drain to 0. So for an NMOS transistor, when G is equal to 0, which means when gate voltage is 0, the transistor is off. We can say that an open circuit and there is no current flows from drain to source. Suppose when G is equal to 1, when gate voltage is equal to 1, we say that the NMOS transistor is on. Whenever it is on, there is a closed path from drain to source, which indicates the current is flowing from drain to source. Next, we'll consider PMOS transistor. So this is a circuit symbol of an PMOS transistor. So when G is equal to 0, so when G is equal to 0, when it is transmitted to here, its value becomes 1. So when it is 1 means there is a closed path which indicates flow of current from drain to source. Suppose if it is value is 1, when it is complemented, here we are having this bubble. This bubble indicates it performs inversion or complement. So when you are giving input as 1, its complement is 0. When it is 0, then we can say this circuit as open circuit and there is no current flows from drain to source terminal. This is how the transistors can be accessed switches. So the condition for NMOS transistor, it is on only when G is equal to 1. And the condition for PMOS transistor is it is on only when G is equal to 0. So next, we're going to see the CMOS inverter. So here, the figure shows the schematic diagram of an CMOS inverter. The figure shows a schematic diagram of an CMOS inverter. So it consists of pull-up PMOS transistor and also pull-down NMOS transistor. The CMOS inverter consists of pull-up PMOS transistor and pull-down NMOS transistor. Here, the bar should indicate the VDD and this triangle which indicates the ground. Here, the gates of both transistors are tied together and give as an input A, and the drains of these two transistors can be given as output Y. Coming to the truth table of the CMOS inverter, suppose if you are giving 0, as an input at the A, the PMOS transistor value is 1, so that it should be on, and the NMOS transistor value should be 0, so that it is off. So when the PMOS transistor is on, the output Y is pulled to VDD and VDD value is 1, so that if you are giving input as 0, the output is 1. So if you are giving input as 0 at A, the PMOS transistor should be on, the NMOS transistor should be off, and the output Y is pulled to VDD, so the output is 1. Suppose if you are giving input as 1, the PMOS transistor should be off, because when you are supplying input A as 1, when it reaches to PMOS transistor, here the 1 should be converted to 0, and even for NMOS transistor, it is 1 only, the NMOS transistor should be on. When the NMOS transistor is on, it is connected to ground. The output is tied to ground. The ground value is 0, so that the output is also 0. So if you are giving 1, the output is 0. If you are giving 0, the output is 1. This 1 is due to VDD and this 0 is due to ground. So this is the simple operation of CMOS inverter.